Arithmetic Series. Good day everyone, this is Teacher Astrid for another lesson of Pinoymath. Our objectives for today are: number 1, to define arithmetic series. Number 2, to derive the formula for the sum of the terms of an arithmetic sequence. Number 3, to find the sum of the terms of an arithmetic sequence by using the formula. And number 4, to appreciate and apply arithmetic series to real-life situations. We have learned that the nth term of an arithmetic sequence is given by the formula a of n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, d is the common difference, and n is the number of terms. We will start with our new lesson by considering the following problem. Irene works in the City Health Department. She was asked to get the total number of persons under quarantine inside the Quezon Memorial Circle. Due to space limitations, she was told that the beds are arranged in such a way that the first row has 10 beds and the next rows are 4 beds more than the previous rows. If the nurse told her further that there are 12 rows, how many beds are there on the last row? And if Irene was to record the capacity of the facility, how will she be able to know? It is given that the first row has 10 beds, the second row will have 14 beds, the third row will have 18 beds, and so on until the 12th row. Writing the numbers in sequence form, we have 10, 14, 18, and so on and so forth until the 12th term, which shows an arithmetic sequence with a common difference of 4 and a first term of 10. To determine the number of beds on the last row, we'll have to use the formula a sub n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub 1 is equal to 10, n is equal to 12, and d is equal to 4. Solving for the number of beds at the last row, we get a sub 12 is equal to 54. Hence, there are 54 beds on the 12th row. Given the previous informations, how will she be able to know the total capacity? Irene may list down the beds of each row and add them. Adding the number of beds for each row, we will have the sum as 10 plus 14 plus 18 plus 22 plus 26 plus 30 plus 34 plus 38 plus 42 plus 46 plus 50 plus 54 is equal to 384. Therefore, there are 384 beds in the facility. The indicated sum of the terms of an arithmetic sequence is called an arithmetic series. In our example, 384 is the sum of the sequence up to the 12th term. When the terms of an arithmetic sequence is joined by the plus symbol, it means that you are to add them and the sequence becomes an arithmetic series. For the sequence 10, 14, 18, 22, 26, and so on, we have the summation up to the first term as 10. We have the summation up to the second term or S of 2 as 10 plus 14. Therefore, summation up to the second term is equal to 24. We just add the first term and the second term. The summation up to the third term, or S of 3, is equal to 10 plus 14 plus 18. I-add natin yung unang tatlong terms. Yun ang summation up to the third term, and it is equal to 42. And we all know that the summation up to the 12th term is equal to 384. We are now to derive the formula for the sum of the terms of an arithmetic sequence. To do this, let us list and add all of the number of beds per row, giving us a total of 384, and this will be our equation 1. In equation 1, we started with the first row going to the last row. If we write the terms in a reverse order, we can still have the same sum. So we start with 54 and end with 10. It will also give us the sum of 384. We will now have this as our equation 2. Adding equations 1 and 2 vertically and denoting the sums as S of 12, we have the following equations. Makikita natin na bawat column ng mga terms, pag in-add natin ay 64. Yung 10, i-add natin sa 54, yung mga unang terms sila, pag in-add natin 64. Yung 14, i-add natin sa 50, ang answer din ay 64. Ganito ang makikita natin hanggang sa last terms. Since there are 12 terms, we will have 12 sums, which are 64. To get the sum, we will just multiply 64 by 12. The sum is therefore equal to 768. But notice that this sum is equal to 2s of 12. 2s of 12 means it is twice the exact sum. To get the actual sum, we will have to divide 768 by 2. Therefore, the summation up to the 12th term is equal to 384. In general, if S of n represents the sum of an arithmetic sequence, we can now write the sum of the terms of the arithmetic series as S of 1 is equal to A sub 1 plus A sub 1 plus D, which is the second term, plus A sub 1 plus 2D, which is the third term, and adding all of the terms up to the last term, which is A sub n. That will be our equation 1. Rewriting the terms in the reverse order, we'll have S of n is equal to A sub n plus A sub n minus D, which is the second to the last term, plus A sub n minus 2D, which is the third to the last term, and so on up to the first term. That will be our equation 2. Adding the two equations vertically and simplifying, we have S of n is equal to n times the quantity A sub 1 plus A sub n all over 2. The sum of the terms of an arithmetic sequence is given by the formula S of n is equal to n times the quantity A sub 1 plus A sub n all over 2, where S of n is the sum, n is the number of terms, A sub 1 is the first term, and A sub n is the last term. To help you understand this lesson, we will have the following examples. Example number 1. Find the sum of the first 30 counting numbers. Since counting starts with 1, and for the first 30 counting numbers, we have 1, 2, 3, 4, up to 30. The 30th term is therefore 30. And the number of terms, since we are dealing with the first 30 counting numbers, is 30. By using the formula and substituting the values, we have S of 30 is equal to 30 times the quantity 1 plus 30 all over 2. The sum of the first 30 counting numbers is therefore 465. Example number 2. Find the sum of the first 16 terms of the arithmetic series 10 plus 16 plus 22 and so on and so forth. Since the last term is not given, we will have to find a's of n or a's of 16. A's of 16 is the last term. Given that a's of 1 is 10, n is equal to 16, and the common difference is 6, we'll have a's of 16 is equal to 10 plus the quantity 16 minus 1 times 6. Solving further, we have a's of 16 is equal to 100. Substituting a's of 16 to the summation formula, we'll have S of 16 is equal to 16 times the quantity 10 plus 100 all over 2. The sum of the first 16 terms of the arithmetic series is therefore 880. An alternative formula which we can use in getting the sum of the terms of an arithmetic sequence is S of n is equal to n times the quantity 2a's of 1 plus n minus 1 times d all over 2. We can use this when a's of n or the n term is not given. Substituting the given values, you will also be getting S of 16 is equal to 880. Whichever of these two formulas will be easier for you to use, then you can have it your way. Again, we will define arithmetic series as the indicated sum of the terms of an arithmetic sequence. When a's of n is given, we can use the formula S of n is equal to n times the quantity a's of 1 plus a's of n all over 2. If a's of n is not given, then we have to solve for it and substitute it to the formula of the summation of n. An alternative formula is S of n is equal to n times the quantity 2a's of 1 plus the quantity n minus 1 times d all over 2. Try the following. Number 1. Find the sum of the first 20 terms of an arithmetic sequence whose first term is 15 and whose last term is 146. If your answer is 1,610, then you are correct. Number 2. Find the sum of the first 50 positive odd integers. If you got a's of 50 is equal to 99 and summation up to the 50th term is equal to 2,500, then you are correct. That ends our lesson. Again, please don't forget to hit the subscribe button and the notification bell to get more videos of Pinoymath. Happy learning!